Hi everyone. Welcome to the today's chemistry session. We will break down Lewis dot structures and formal charges step by step. Let's make chemistry visual and easy. A Lewis dot structure is a diagram that shows only the valence electrons of atoms that involved in bonding. Dots are used to represent electrons. You will see lone pairs and bonding pairs clearly. So the Lewis dot structures are the visual representation of valence electrons around the element symbol. So if we have, for example, hydrogen as shown in the picture, there is one valence electron in hydrogen, so it is represented as in the form of dot. But when we talk about oxygen, we have seen that there are lo- two lone pairs. These these closely placed dots are shows the lone pairs in oxygen, and there are two other electrons shown which are involved in the bonding during the reaction. So now we will move towards the next slide. Here we will calculate how the total valence electrons are counted using the Lewis dot structure. We have carbon and hydrogen in methane. So carbon, when we see carbon has four electrons, four valence electrons in its outermost shell. And when we'll talk about hydrogen, hydrogen has only one electron. So how to give the Lewis dot structure to any element? First of all, in the first step, we have to count the total valence electrons. So carbon has four valence electrons and hydrogen has one. But when we see the structure of methane, we came to know that it has four hydrogens attached with carbon like this CH4. It has four bonds made with it made four bonds with hydrogen. So there are four hydrogen and one carbon atom and four hydrogens are present in methane. So what happened, there are four valence electrons of carbon and valence electron of hydrogen. So for four hydrogens there are four valence electrons, so total number of valence electrons are 8. So we have to choose the central atom. For the Lewis dot structure, we have to choose the central atom, and always the less electronegative atom we usually placed in the center. But in the case of methane, we have seen that carbon has the electronegativity of like hydrogen has is more a carbon is more electronegative than hydrogen because carbon has electronegativity of 2.55 on the Pauling scale, but hydrogen has 2.2. Then why carbon is placed at the center? Because carbon has the ability to make four bonds, so we will place carbon at the center. But in this case, hydrogen has the ability to form only one or single bond, so we cannot place hydrogen in the center. So in the third step, connect each hydrogen to carbon using a single bond. Like first of all, we have to make the dots around carbon. Like we have four valence electrons in carbon, and we have hydrogen, four hydrogen that will make bond with the carbon. So we will show their valence electrons in the blue color and the valence electrons of carbon in the orange color. So what happened here? First, we will make single bonds like these two valence electrons, one of for carbon and one for hydrogen, make a single bond. Now see, look at the other valence electron of carbon and hydrogen, they also make a single bond, and here there is a third single bond and here is the fourth single bond. So we use four bonds here. We make four bonds. Four bonds are formed here. It means each bond has two electrons. So four bonds have eight total number of electrons. So it means it fulfilled the octet rule. So it is now stable. That's why we show the Lewis dot structure. to complete the octet or duplet rule. Now we have to calculate the formal charges. How to calculate the formal charges? Formal charges, we can calculate the formal charges by using valence electrons, non-bonding electrons, and bonding electrons. Here we will subtract valence electrons, non-bonding electrons with valence electrons, and then add bonding electrons divided by 2. So valence electrons, number of valence electrons in the free atom are represented by V, and number of lone pairs are those electrons which are not involved in the bonding. They are non-bonding electrons. And the bonding electrons are those which are shared in the covalent bonds. So here we will calculate the formal charge on oxygen in water molecule. Like we can see that in oxygen, oxygen has two lone pairs and two electrons which are involved in the covalent bond. There are two hydrogen atoms connected or make bond with oxygen, and these are the valence electrons of hydrogen. And we have seen that there are six total valence electrons in oxygen. So what happened here? Here this valence electron of hydrogen and this valence electron of oxygen make one bond, and now this valence electron of oxygen and this valence electron of hydrogen make another bond. So there are two new bonds are formed, and these two lone pairs are present on the oxygen, which are not involved in the bonding. So total number of now we will calculate the total number of valence electrons in oxygen. That there are total valence electrons in oxygen are valence electron in oxygen are 6. Now what are the number of lone pairs? There are there are two lone pairs. Lone pairs are 2, and number of lone pair electrons are 4. 4 lone pair electrons on oxygen atom. And bonding electrons, how many bonding electrons are there? They form two bonds. It means there are in two bonds there are 4 bonding electrons involved. But when we put them in the formula, like which is formal, how to calculate formal charge? Valence electrons subtract, then we have valence electron, then we have lone pair electrons plus bonding electrons divided by 2. So valence electron on oxygen atom are 6 minus lone pairs. Lone pair electrons are 4 plus bonding electrons. Bonding electrons are 4. Total bonding electrons divided by 2. So when we solve this, we will find out 6 minus 4 plus 2. We will divide 4 by 2, then will come 2. Here is 0. So the oxygen atom in the water molecule is neutral because its formal charge is 0. And why we will have a Lewis-Dot structure? We have more than one Lewis-Dot structure, which shows the resonating structures of any element.